99.
That's a 3, isn't it?
Justin, what two factors did you break it up into?
11 and 9.
Okay, very good. Square root of 11 and square root of 9.
It's a 3.
Okay, which one can I simplify?
The x is
I didn't
What?
9.
No. 2.
With this?
Would you like to
You asked
show
for
them
x's.
how
So
to
it's going to be square root of 11 times 3. Remember, it acts like a variable, so we always want to put it in front.
Why don't
Can't
you use
simplify this
it?
anymore, right?
You don't even know what the right answer is.
I want them to know.
Okay. So, square root of 27, square root of 49.
There you go. Good job. What? How did you get that?
Right?
Was
That's
it
our
right?
first step in simplifying. We're just going to break up your fractions.
How's up with the
Because you can't divide square root by square root. That's okay. So next thing I want to do is look for perfect squares. Do I have any perfect squares, Jason? I can simplify that one. Awesome. Kyle, do I have any other perfect squares that are factors of 27? 9 and 3. So this one becomes the square root of 9 times the square root of 3 over 7. Okay. Easy little trick. If you do find a perfect square, stick it in the front. And when you simplify it, your number's already in the front.
No, it's because
Just start to organize your thinking. Helps to keep it in order. So Sarah or Jason, try to simplify this for me on top. What you can.
Wrong wish.
yeah, we divided.
Good.
Wrong wish.
Okay.
No.
Can I simplify your 3 any further, Sarah, and get a nice prime number? It's prime. So it's 1 times 3, square root of 3 is something crazy in your calculator. Now, with this one, Justin, can I simplify this fraction at all?
No.
No. So this is if you can simplify your fraction, you need to. And remember, this is like a variable. So if this was actually, let's say it was 3 root 3 over 3. This is kind of like 3x over 3. What can I get rid of?
No.
So then I just do that. So the square root of 64 times x. So my first thing I want to do is I want to break it up. What two pieces am I going to break it up into?
Okay.
X to the 4. We're going to get to this one.
1.
So this is the same thing as the square root of 64 times the square root of x to the 4. I do that because those are, they can be dealt with differently because they're kind of on the thing where you
The
have
opposite sides of a quadrilateral are congruent.
Here's your first blurb, it's chapter 6. Rule of exponents.
I discussed the question.
We have an exponent,
Out of the book.
okay, so we have an x to the 4th, or I'm sorry, x to the n, right? And n is going to be equal to any numbers that, well, it's another way. Here's this. That's an example.
Were you telling me you were talking?
When I have exponents, that's the same thing as doing x to the 1 times x to the 1 times x to the 1 times x to the 1.
So,
Right? In theory, that's what x to the 4th means. X and x to the x. So how can I go, if I look at my exponents, the way I end up with this one is I add them
Are
together.
we?
Right? So I can split up this number into any
No, we can't.
amount of values with exponents, as long as those exponents add to that number.
It's both.
So I can break it up. So for this one, with square roots, this one does squares, right? So what I want to do first is subtract out squares, and then you deal with what's left over. So if your exponent is even, you should get in, you should have no leftover x's, right? So this one will go to x squared, right?
Just like paraphrase.
Times x squared. So let's say it was x to the 5th.
you can use properties of congruent.
I want to take out x squared and just keep going. So it starts with x squared and x to the 3rd, right?
Okay.
I can pull another square out.
Yeah, very good.
Make sense? So when I simplify this, what's this going to turn into, Justin? What do you think? If it undoes the square, what will it do? Well, the square root's not
Oh,
going to
is it just x?
Yes, very good. So this one Kyle's going to be? Jason, can I simplify this? So what's this going to be? Okay, alright. But my combining like terms? Sarah, what can I combine and simplify?
If the diagonals of the quadrilateral bisect each other,
X plus X is 2X. What's X times X?
means that if the diagonals of the
Wow.
Okay, so we're going to apply this in this problem. So we already split this up. Kyle, is there any perfect square for 64?
So
Awesome. So it's going to turn into 8. Is it just 8? Can it be any other value? No, just 64. Is it just 8, or is it something else possible?
Yeah, could you possibly make that easier?
We always forget that. Yeah.
not really, because
So really, it's the absolute
It's not in
value,
the book.
right? Or you can write it like this,
explained.
or you can write it like this. I will accept both of those.
so everybody look here.
Now let's look at this one. Justin, what is the square root of x squared going to become?
X.
This one too, right?
So example 2,
Jason, simplify for
figure
me.
has two pairs of sides that the figure is a parallel by theorem 8
So this would break down like we have to the square root of 4 times the square root of 13 times the square root of x squared times the square root of x, right? Times the square root of y squared times the square root of y squared times the square root of y. Yeah? Okay, simplify. 2 times root 13 times x times root of x times y times root of y. Now I can combine anything I can combine, including things that are under radicals. If it's under a radical, it can all go back together, smush together like that a times b. So then I'm going to get 2x y squared square root 13xy. If you get to this place, you'll get a lot of credit. You'll probably miss a point if you can't get to like say you just left these as like root 13, root x, root y, you lose a point. But if you can get to this step, you can get to this step. Okay. This guy Descartes, he decided, he's like, alright, well, if it's not real, we can pretend like this. So he decided that this whole thing can actually be defined by this number I, such that instead of an x, this imaginary number, if we square it, we get -1. Okay? So I, then, is going to be equal to the square root of -1.
So if you ever get a square root of -1, it turns into I.
Yep, very good. Woo! Nice job. Okay, so let's try an example. Let's look at the square root of -18. Remember, now, for this one, we first want to break it into factors. Okay, if we have a negative, we're going to want to pull out that square root of -1 factor, because then it helps turn our number into a positive number. Okay, so we start with the square root of -1. Then we look for factors that are perfect squares. Jason, are there any factors of 18 that are perfect squares? 9 and 2 is definitely a perfect square. Okay, simplify it, Sarah. What you can.
The one that's highlighted is mine.
Here you go, right?
Okay. Yep. Times your 2. Okay, I is like a variable, so please put it after your numbers. So this is a strategy I use. I always take it out first, so it starts in the front, and then I just put it back into the next step, like the next thing. So this will simplify to 3i. Try the square root of -125 x to the 5th, because this can also apply to variables. It's going to be the same way as you guys did the other one with the variables, but now we've added in an I. So Justin, this is the first thing I want to pull out. Yep. So my first factor is going to be, very good, square root of -1. Next thing I want to look for is perfect squares that are factors of 125. So Kyle, can you think of a perfect square that's also a factor of 125?
Oh.
Very good. If I divide 125 by 25, I get 5. So here's my my trick. For those of you guys that kind of struggle with finding factors or have trouble getting there, take your number, okay? And in your mind, if you need to make the list and just have that list with you, that's fine too. Write all the perfect squares. So 1, 4, 9, right? This is like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10. If you at least do it up to 13, those are real common. So if you have this in your notebook, right? Okay, and then 16, 25, 36, 39, 64, 81, 100, 121, 144, 169. And this is how I memorized it when I was in school, and how I just know it now, because I just created this for myself. Yeah, I just kind of stuck with it. So then what I would do is I'll go to my calculator, and I'll take this number, and I'll start dividing it by all of these. So if I do that, and I get another whole number, I use it. Okay? So then if I divide this by 25, I get 5. Stop. So that's a nice small whole number, and I know it has no factors that are equal to squares. But then it also allows you to see if there's other numbers like that. Because let's say this number was bigger, if it was 50, I can do that again, right? I can go back through my list and see if I can divide out another one. It takes a little bit of time, but it's to me more efficient than like guessing. Or just going down the factor list for that number. Because you have like something you're focused on, you're trying to find a perfect square. Does that make sense? So anyway, that's a strategy I use, that's how I do it now. You know, it helps me. It helps me. Oh, sorry, I'm not done. What else can I pull out, Kyle?
Root x squared. Root x squared.
So that goes up my 5. Now I can start simplifying. Square root of -1, Jason. Very good, Justin.
Sorry.
I'm glad that you know it. Square root of 25.
5.
Kyle, did I do anything with this?
Nope.
Sarah, square root of x squared. Square root of x squared again. Square root of x. Very good. I'm not trying to trick you. It's most obvious. Okay, what can I simplify and or combine? Justin.
The x's.
Okay. What else, Kyle?
Combine the
You know it.
ones that are the roots.
Yep, the ones under the radicals. And what else, Jason, can I stick together?
5. Yeah, the 5 and 5.
Yep, the 5i, right? And that's going to also go with this x. Yeah? Simplify, just get rid of your dots. Okay?